All right, grade 12s, welcome back again on our organic molecules. I'm going to take you through the question 5, and I want you guys to listen carefully in terms of how to write the IUPAC name and how to draw. It's very, very important that you pay close attention. According to this question, it's very, very easy because we just gave you one structure, unlike when we give you multiples of them and so on. So this it's very, very easy. The purpose of this lesson is for me to help you how to draw and how to write down the IUPAC names. I'm very, very worried about that because it's all about naming that now. So in your term 1, it's all about naming and being able to give the IUPAC names and so on. So I believe you have studied the homologous series. If you haven't, please refer to the link that I'm going to share on the bio so that you guys can be able to refer to that video. I'll just put it on the description. So according to this, we need to analyze what we are having here, and we need to underline the main chain. Looking at this structure, let me choose a different color. Looking at this structure, someone can say, okay, I choose to go with this, but it won't be necessary because we don't, you have 1, 2, 3, 4 carbons. So why not just go with the straight one and have 1, 2, 3, 4? It will still be the same because you have a branch now at number 3. So even if you turn like that, you will still have a branch at carbon number 3, so it won't make any difference. Sometimes you're going to have to take the L shape based on the number of carbons. For an example, sometimes you find out having 1, 2, 3, 4, 5, and then we do this, and then someone says, okay, well, I think I have a butane and I will have ethane as a branch. That would be a better idea because look at the longest chain. Rather go with the L shape, knowing that you have 1, 2, 3, 4, 5 carbons, and you'll have a methane as a branch. So whenever you have ethane as a branch, please think twice. Think very carefully whether that is a branch or you have to turn and take the longest branch. Take the longest chain. So it's very, very important to consider the chain. So but then in this question, it's okay, we have a butane. This is going to be our branch, and we have the double bond. So immediately we have a double bond. This is definitely an alkene, isn't it? This is definitely an alkene. You see, another thing is that when you look at this, this is carbon number 1, carbon number 2, carbon number 3, carbon number 4. However, as for the bond, this is bond number 1, bond number 2, bond number 3. You don't have bond 4 there. This is just the hydrogen, so don't count it. So you basically have 3 places where the double bond can be placed. So that means looking at this, the double bond is in the middle because you have one last space and one last space. So why am I doing that? My point is sometimes you'll be having something like that and we put a double bond there. When you know this is 1, 2 and 3, and 4, your double bond will be on the number 2 rather than to start from the left to the right and say 1, 2, 3, 4. So always when you name, check whether the double bond is more closer to the first. Okay, rather name it where the double bond is closer to the first than where it is further to the first, because now you'll be having a double bond at number 3. So it will be a bad move. Just say, okay, my double bond is more closer to the first carbon, so I'm going to name from the left to the right. Okay, well, it's going to make sense very soon, never mind. Looking at this, they said you need to define unsaturated compound. We know that when we talk about unsaturated compound, we talk about a compound with two or more double bond. Because when we are looking at saturated are only compounds with single bonds, right? So this question, it's very, I'm going to be very strict with you because we won't be discussing such things at later stage. I don't think I will be teaching you how to define unsaturated compound. You must know, very easy. Okay, so just tell them that it's a compound with one or more multiple bonds between carbon atoms in their hydrocarbon chains. Okay, I'm going to repeat: compounds with one or more multiple bonds between carbon atoms in their hydrocarbon chains. So you can learn other definitions in your book. Write down the IUPAC name for the compound. Like I told you, this is how you start naming. Let's identify then the double bond. Double bond is in the middle. So since it's in the middle, the methyl, it's on number 3. I can start this side because it's in the middle. So we rather say on the third one, because I want to count from I want to count from the right to the left because my branch is more closer. Again, this is very important. It's more closer to the first because now you're looking at, okay, it's 1 and 2. So it's better going 1, 2, and 3. You see? So when you look at a branch, check whether the branch is closer to the first. So rather name it in reference to the first than to the last that is more further away from it. So when you name this one, you are definitely going to say to us, on the number 2, I have a methyl. Okay, number 2, I have a methyl. Sorry, methyl. So it's methyl. How many carbons do you have? 1, 2, 3, 4. So this is going to be a but, and then now you can count from, you see, when you're looking at that, it will be 1 and 2. So it's 2 in. So that's how you can name that 2-methyl but 2 in. Okay, someone can say 2-methyl, 2-methyl, and then and say and 2-butene. It will still be okay. It's up to you. You can say 2-methyl but 2 in or 2-methyl 2-butane. Okay, now butanoic acid is a functional isomer of methyl propanoid. Let's just talk about this a little bit. A functional isomer. When we talk about a functional isomer, we talk about compounds that have the same molecular formula but different functional group. I'm gonna need you guys to pay close attention because I want to take you here. Oh, my sideboard is gone. Let me just go back to it. So it's very important that we understand what a functional isomer is. Once we understand the definition, we will be able to get this. So let's see. Let's find an empty space. Looking at the word functional isomer. Functional isomer. You can check in your book. Functional isomer, compounds with, let me say, with the same molecular, with the same molecular formula but different functional group. Different functional group. we want to understand what does it mean when they say isomers are compounds with the same molecular formula but different functional group. When we talk about a functional group, starting with the functional group, we have something like renalidine, alkanes, alkenes, alcohols, and so on. You name them, esters, and so on. And we have two pairs of functional groups all the time. We always have two types, okay, two pairs rather, of functional group. Starting with aldehyde, I want you to look at the word al there, or rather aldehydes, okay, aldehydes and ketones, because before we go to the ketones, we start with aldehydes. So as a result, this is a functional group, and this is a functional group. Look at an example of an aldehyde. How do we know something is an aldehyde? Well, looking at that, we see something like 1, 2, 3, 4. I'm going to say 4. We know it's an aldehyde when it has a double bond on its last carbon, not in the middle. So this is the same as, it's just the same, this is the same, guys. I want you to pay close attention. This is the same, just that I decided to place the double bond on the last one. If I want, I can place it here. So, but all in all, we know it's an aldehyde when we have a double bond on the first one. But with the ketone, it's quite different. It will be something like 1, 2, 3, 4. It can be on the first or the second because it will just resemble the previous one. So it will be somewhere in the middle. It can be here or it can be there, So that's why these two are isomer or functional isomer of each other. Aldehydes and a ketone, they will always go together. Esters and carboxylic groups, you will see them, okay? So that means they can draw something like that and say draw its functional isomer. That means you have to decide to place double bond either on the third or on the second. So they are always functional isomer of each other. And looking at the number of hydrogens, we have 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Do you realize that if you were to write the same molecular or the molecular formula, because when we talk about a molecular formula, we talk about the molecular formula. I want you to check what molecular formula is. Same molecular formula. Looking at this, you'll be having something like C4 and then H. How many H's? 1, 2, 3, 4, 5, 6, 7, 8. So you'll have 8 and only 1 oxygen. Check. You go to the ketone, you do the same thing. How many carbons? 1, 2, 3, 4. You have 4 of them. How many hydrogens? 1, 2, 3, 4, 5, 6, 7, 8. You'll have 8 of them and only 1. So can you see that they have the same molecular formula, but they belong to a different group? That's what a functional isomer is. So when we say to you, write down or butanoic acid is a functional isomer of methyl propanoid. They are referring to carboxylic acid. So let's talk about carboxylic acid or carboxylic group. When we talk about carboxyl group, these are very easy because if I have something like 1, 2, 3, I will have a double bond on the last one and have an alcohol So this branch is what we are looking for. Once we see that kind of a branch, we know it's a carboxyl group. And when you name it, you just count the carbons 1, 2, 3. So and say propanoic acid. See, propanoic acid. So this is your, if it's a butanoic, it means they have something like that. So that is the structure of a butanoic acid. I hope you can see clearly. So with that, now they said, okay, a functional, butanoic acid is a functional isomer of methyl. Of course, we talked about an aldehyde and a ketone. Even the carboxylic acids, they are a functional isomer of esters. So write down the name of a functional group of butanoic acid. Like I told you, when you name a carboxyl group, they end with a noic. So to answer this question, we know that this oik thing, they are carboxyl group. They are carboxyl. If you haven't learned, you have to refer to that video. They are carboxyl group, right? Carboxyl group. If I have 1, 2, and I have a double bond and an alcohol, how do I name it? Is 2. So it's just going to be ethanoic, right? Ethanoic acid. They are carboxyl group. So now they say draw the structure of a formula of butanoic acid. Well, I already did, isn't it? I already did. Just say 1, 2, 3, 4, because but it's for 4 carbons. That means you just have to put a double bond on the last one and then put an alcohol. Don't forget to draw the hydrogens, because they will penalize you if you draw it naked, as I always do. But to save time, I always make sure that I don't draw the hydrogens. But as for you in the exam, you make sure you draw the hydrogens. Draw the structural formula of a methyl propanoid acid. This is now an ester. Let's go and talk about an ester. As we talk about an ester, this is how you name them and this is how you draw them. Esters. Let's talk about them. Esters. When you talk about an ester, you talk about, or rather, we notice something about such structures. We know that a normal chain is just carbon carbon. Oops, what am I doing? It's just carbon. How, my daughter? What's happening? What did I do? Because this is going to be unacceptable. What did I do, Kant? Okay, let me pause and fix this. Or rather, I'll just use this because it wastes my time. So it will be something like 1, 2, 3, 4. So when we have a normal chain without any oxygen in the middle, but when we look at the ester, we notice something quite interesting. We're like, no man, hang on. We realize that the chain has oxygen in the middle. How did that come about? We know that is an ester. So when you name an ester, and I want you to look at this very carefully. When you name an ester, because this is how ester looks like, you'll be having something like oxygen, hydrogen, 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 hydrogen. The part with the double bond will go together with the oxygen, and this will be the last part. So when you give a name, you start this part. You start with this part. Since it's 3, it becomes propyl. Propyl. If maybe you had only 2, it will be methyl. If maybe there are 4, it will be butyl or butyl. So it's propyl, methyl, butyl, pentyl, and so on. So that's how you name an ester. So it's propyl, and then now you look at the other part is 2, so it's an ethane, so you say ethanoate. Ethanoate, okay? Ethanoate. So that's how you name an ester. You start with the part that doesn't have it, or you say propyl if there are 3, and so on. So sometimes they can do something like, let me try to fix this. I don't know what's happened to this guy, because I cannot effort. Okay, all right, it's fine. So let's look at another example, because I don't want you to cram. Sometimes you find 1 2, and then you find something like that. They can flip it, so just because I circled this part on the previous example, that doesn't mean you should. When I look at the double bond, that part should go with the oxygen. So when you name, you start with this part. Since there are 2, it will be ethyl. It will be ethyl. Now that there are 2, it will be ethyl, ethanoate, ethyl, ethanoate. So that's how you name an ester. Let's look at this. They said, okay, now go and draw. So when you draw this methyl propanoic acid, you know this part is the one with the thing. So methyl, it will be the other part without the O. So it will be easy for you to just say, oh, okay, hang on a minute. That means I have to start with 1 2, since they are together, and then put the oxygen. Then since it's propanoid, they're going to be 3 1 2 and 3, and that means I should put my oxygen here, because this is the noid part, right? That is the noid part. So then you draw your hydrogens just like that. So that's how you're going to draw that structure. Explain why butanoic acid and methyl propanoate are described as functional isomers. Yes, we know why they are described as functional isomers, because they have, this is the reason. Explain why. You can say because they have the same, this is basically a definition for a functional isomer, because they have the same molecular formula. Sorry about my handwriting. Because they have the same molecular formula, but same, but different functional group, isn't it? Because a functional isomer, it's when compounds have the same molecular formula but different functional group. Right, we got it. Now, write down the IUPAC name for an alcohol used to prepare the methyl propanoid. It's sort of a framework, but not necessarily. You look at the you look at the word methyl propanoid. We want to know which part it's for an alcohol. Okay, which part it's for an alcohol is the part that doesn't have the O, because as we drew 1 2 3, and then we did this and we did this and said 1 2, this part that doesn't have or rather, even if you can check, it's like you have an alcohol, because when you name an alcohol, or when you draw an alcohol, you just say OH. Can you see that? So that means it's like they took this part and then divorced the hydrogen. So you know that an alcohol doesn't have carbon and a double bond, and also oxygen. That is the carboxylic group. So looking at this structure specifically, it's very easy to say, no man, I think I know where the alcohol is. It can't be this part. This part, it's for the carboxylic, right? But the alcohol will be this part. So it's your methyl. So if it's methyl, then that means the name of an alcohol that has 2 carbon is ethanol. So you write ethanol. I hope that makes sense. Okay. Now, Write down the IUPAC name of a positional isomer of methyl propanoid. Think about that. Write down the IUPAC name of a positional isomer of methyl propanoid. This is about exchanging, isn't it? This is about exchanging because think about this. Let us draw methyl propanoid. 1, 2, 3, double bond, O, 1 and 2. Position is about placing something on a different position, or on different position. So we can now swap them and write 1, 2, and then O, 1, 2, 3. So whenever we write a positional isomer of an ester, you change the naming. The part with the methyl or methyl is the one that become methanoid, and the part with the noid is the part that comes with the ion. So you'll just simply say, okay, this will be propyl methanoid. Propyl methanoid. So always remember that when it comes to the ester, should I be given a random ester and be requested to write its positional isomer, that means its positional isomer will swap, right? Will place the alcohol on a different position. So that means we are going to change the naming. The ending will go to that one, and the ending of that one will go to that one. So you'll end up having propyl methanoid. I hope we got it, guys. This is 18 marks, and you make sure you get this right, and you will never go wrong. It's all about practicing, treating so many questions, and then you're gonna get there. So with that, guys, I will definitely see you later.